The times taken by garage to fit a tow bar onto a car have a normal distribution with mean m hours and standard deviation 0.35. So I'll start by writing that x is normally distributed with the mean m and the variance 0.35 square. It is found that 95% of times taken are longer than zero point 0.9. So the probability that x is more than zero point 0.9, that is equal to 0.95. Okay. So we have to find the value of m. So, we always start from standardizing it. So this now becomes probability z is greater than zero point 0.9 minus m over this 0.35, that is equal to this 0.95. Okay, so you see that there is this greater seen here. So this has to be a negative value because this probability is more than zero point 0.5. Look at this. If I just show you over here, okay. So 0.95, there's greater than sign. So this means this is going to be somewhere over here, this zero point 0.9. Okay, so that is why all of this is going to be 0.95. So we have to make it forcefully a negative value. The probability z is greater than, I'll take a minus common from here. This is m minus zero point 0.9 over 0.35, and that is equal to 0.95. So now this becomes, there is a greater sign, there is a minus, so this is directly phi of m minus zero point 0.9 over 0.35, that is equal to 0.95. So then we can write it as, this then becomes this m minus zero point 0.9 over 0.35 is phi inverse of 0.95. Okay, if you go down here, so this is here 0.95. So this is 1.645. So these are the critical values. These are very typically used. So we can find this probability of the z value very quickly from here. So it's 1.645. 1.645. Where are we? 1.645. So this m minus zero point 0.9 is 0.35 into 1.645. So we have this m here. This is 0.35 times 1.645, and then plus that zero point 0.9 into it. So this m is going to be 1.47575, and for the sake of the answer, this is going to be 1.48. That is the m we have right now here. Okay. Next, it says on one day, 4 cars have a tow bar. Find the probability that none of them makes more than 2 hours to fit. This is the same question we have done here. I think. Where has that question has gone? Yeah, where there was a combination of a normal and a binomial distribution. So guys, for this question, um, you see there is a binomial, an underlying binomial distribution here. And to handle that, let me just draw a line here. Okay. So now this, for the second part, you have, there is, let's say this y is a binomial distribution. Its n is 4, and you still have to calculate the probability of success. And what is that probability of success? That is from this distribution that is up here. We have to find this P is going to be, let me change the color. Okay. This P is actually the probability This is small p and this one is, I'm sorry for that, small p and this one is a bigger p here. Okay, this is x is more than 2. X is more than 2. That is the probability of success for this binomial distribution, where you have to find, where you have, like for this binomial distribution, you have to find the probability that it says find the probability that none of them takes more than 2 hours. So you have to find basically probability y equal to 0 over here. We have to find this. So first we need to go to the normal distribution and we have to find this probability, which is x is more than 2. So let's find that. Uh, this small p is going to be now, I'll standardize this. Z is more than 2 minus the mean, which is 1 point. I should be using this as close as I can over the standard deviation, which is 0.35. Okay, let's use the calculator. 2 minus the answer divided by 0.35. This is 1.497. Okay, this is 1.498. This is 1 minus phi of 1.498. Okay, so let's do that. Let's find it. 1.498. 1.49. This is 9319, and then 8 is 10. This is 1.93, sorry, 11 इसके साथ है, 0.9330, 0.9330. Okay, 0.9330. This is 1 minus 0.9330. So मैं यहाँ पे, let me show some cleverness here. This will be giving me the Q directly from here. Q is going to be 0.933, okay, and P is going to be this one, 1 minus 0.933, so that is 0.067. I'll put it here, okay. So now we can find this probability where y is equal to 0. So guys, can you see that how you have to switch between the normal and the binomial? So this is the level of the past paper, the examination questions here. So we have to find the probability that y is equal to 0. So that is going to be 4, this is 4C0.067 raised to power 4 times 0.933 raised to power 0. So this is going to be raised to power 4. So this is the answer. Point, oh, this is such a small answer. 0.00002015 and correct to 3 significant figures. Yes,
Wouldn't
Beta.
it be 0.07?
I was making a mistake here. This should be 0. Yes, Beta. What a savior you are. Okay. So this has to be 0.933. Oh, 0.933 raised to power 4. Thank you, Beta. A very timely, I mean, call here. This is going to be 0.758. Correct to 3 significant figures that none of those cars had to be told. Okay. Last part. Acha. So the time in hours taken by another garage to fit a tow bar onto a car have the distributions this with this. Find the probability that it takes more than zero point 0.6 mu. So he's asking us, like, there is a distribution which has this mu and the sigma square, okay? And we're given that the mu is 3 sigma, no problem. And then it says where to find the probability that x is more than 0.6 mu. Don't be bothered with all this notation, okay? Just standardize this. Z is going to be greater than, now this is zero point 0.6 mu minus the mu here, okay? And over the standard deviation, which is sigma here, okay? So this is probability, and it says the mu is basically 3 sigma here. Let's simplify this first. This is going to be minus zero point 0.4 mu, and instead of mu, I'll be writing 3 sigma here, okay? Okay, people are entering, so I'm getting stuck with that, okay? So this is cancelled by this. So this is, there's z is greater than sign, I missed that, okay? So probability z is greater than minus 1.2. So there's a greater and then there's the minus thing, so that is going to be phi of 1.2. Let's find that quickly from here. Phi of 1.2, phi of 1.2 is 0.8849. This is 0.8849. That is the answer to the last part. Okay, thank you very much, Bacho.